happen if there was no greenhouse gases?
We die.
You need an extra coat because it would be 10 degrees below degrees below Celsius. That's about 14 degrees Fahrenheit. Cold. 2 coats.
Okay.
Wool socks, mittens, earmuffs, hats, coats. Crazy cold. So if we know CO2 can come out of volcanoes, why do we think humans are causing the change and not volcanoes? What are we doing?
Making more carbon dioxide.
Right. And how are we making more CO2? What are we doing? We are burning coal and oil and natural gas. So here it is, so burning fossil fuels. Like coal, oil, and Tetris. I mean coal, oil, and natural gas. Not Tetris. That's on a phone. And what greenhouse gas did they tell us is trapped in the permafrost? Now he's from Scotland, so he says methane. What do we say? Methane. And I did it in yellow because it was hard to see the red. Methane. How many atoms of hydrogen are there?
2. About 4.
4. And how many carbons? 1. And what would happen if all of the fart gas melted?
It died.
That's okay. I'll help you out. Give you a thought. So large amounts of methane would be released if the permafrost thawed out and became like liquid and gas again instead of solid. And permafrost is just basically like soil that is just frozen all the time. But there's a lot of decaying, there's a lot of plants and things in there that would decay if they were heated up. And so if it heats up, the ice melts, the permafrost melts, all the gases are released, and that's horrible. That's worse than CO2. Methane is worse than CO2 because it really does a really good job of insulating. Too much. Little bit too much. We ready for video number 2?
Yeah.
Did Hank finish writing all the answers down? Okay. Aaron, you're good? Yeah. Lane, do you have a chance to get them all down? Yeah. Okay. All right. Moving on. Now here's an elephant seal. But then we're gonna jump into the ocean.
Oh, that's one of the things from Happy Feet, bro.
Is it from Happy Feet?
Yeah, this one of them things.
Crazy.
They're mammoths.
They hit him without.
All right, so this is another quick, this is like a 5-minute video. Anyway, there are questions. Can you look at the questions real quick before we start? All right, so the questions are, how could a slight raise in water temperature have an effect on the Earth? So what happens if the oceans rise? What would cause an ocean to rise? How do oceans rise? Yeah. Think of a bathtub.
Oceans rise because
Think of a bathtub. If you jump in a bathtub, what happens to the water?
The water goes flying.
It rises up. It gets displaced, right? So what causes the oceans to rise? Where is there trapped water right now?
The Arctic.
In the Arctic and in Antarctica, right? So if all of those glaciers, if those continent glaciers, if they melt, all that water runs into the ocean and oceans rise up. That'll cover up islands, that'll cause cities to flood, bad stuff. Why does white ice at the poles keep Earth cool? And why does the dark seawater, how is the dark seawater affected by the sun? So those are the first, there's 5 questions, that's the first 3 questions. We already kind of answered the first one. But here comes the video. So listen for white ice, or white snow, right? White ice, and then dark seawater.
The average temperature of our planet has increased by 0.7 degrees centigrade over the last century, and it seems likely to rise still further. And that could lead to changes in sea level. Even a very small rise in sea temperature could have a devastating effect. Small islands like the one behind me could be totally submerged. Major cities could be at risk. And the reason for that lies far away from here, where the change is already beginning to be seen at the poles. I am at the very centre of the great white continent, Antarctica. The South Pole is about half a mile away. For 1,000 miles, In all directions, there is nothing but ice. I'm now at the other end of the Earth, in the north, the Arctic. I have been lucky enough to travel in the polar regions several times in the last 30 years, making films about their rich wildlife. The sole object in life at the moment is to make quite sure that he and he alone mates with every single one of them. That's the pain. We must fight. It's heavier even than the adult. These parent birds reunite once they come back here onto their own patch of shingle. But although the Antarctic is virtually lifeless over vast areas, there are one or two smaller oases that keep. Slowly, I began to realize that things were changing in ways that will affect the wildlife and eventually ourselves, no matter how far away from the poles we might be.
So as that goes into the ocean, it raises the level of the ocean by a tiny bit.
This is the ice that covered the Arctic Ocean in September 1980. Since then, there has been a 30% reduction in the area covered by ice. And not only that, what ice remains is only half as thick as it was.
Guys, that was over 10 years ago.
If the sea ice continues to melt at this rate, there will be open ocean in the summer at the North Pole within decades.
All the animals gonna die.
The very whiteness of the snow and ice contributes to the pace of change. Light bouncing off it takes 90% of the sun's energy back into space.
Just to stop talking.
And this has helped to keep the planet cool.
So what happens to the white?
But when the sea ice
It
melts,
dies.
it exposes the dark sea water.
Here's the dark sea.
That doesn't reflect the sun's heat, it absorbs it. So the temperature of the sea rises. Here in the Arctic, the climate is warming twice as fast as the rest of the Earth. And that could have global consequences, including rises in sea level around the world. Climate change is already affecting the lives of not only wild animals, but ourselves, all over the globe. I've spent my life filming the natural world, and I've travelled to some pretty remote and exciting places in order to do so. I've enjoyed every minute of it. But every journey seems to have got quicker and shorter. It's as though the world has shrunk. But then sadly, so have the wild places. The increasing size of the human population is having a devastating effect on the natural world. But fortunately, people are becoming aware of that and doing something about it. And I'd like to think that natural history films have helped in that process. And there are some signs of hope. Animals that I thought might become extinct in my lifetime are still with us and growing in numbers. We now have a better understanding of the natural world than ever. We know how best to protect it for future generations. I can only hope that we will.
Me too, David. Alrighty.
He's not cool.
Are you ready for the question? He's really cool, actually. So how could a slight rise in the water temperature have an effect on the Earth?
It would kill a lot of animals. Floods.
What did you write down? Did you write down that it could lead to the melting of the glaciers, maybe? Is that what you wrote? Melting glaciers? And then what happens when the glaciers melt?
The earth explodes.
The rising sea level, right? Sea level rise, just like a bathtub, okay? At the poles, which could cause a change in sea level. So more water in the oceans. What happens to those beautiful little, those little islands in the Pacific that are really, really close to the water?
They spontaneously can rise.
They get covered up. They're not there anymore. Less land for animals to live on. Well, for terrestrial animals to live on. A lot of cities, like 80%, I think, like in a ridiculous number of people, live near, like within like 100 miles of the ocean. So lots of really, really, like the biggest cities on the world, on the planet, are really, really close to the ocean. So a lot of those are going to flood too. Kind of scary. So how does white ice at the poles keep the Earth cool? Yeah.
It bounce like the sunlight bounces off the ice and then goes back up.
That's right. Emily, you said bounces off too, right? Perfect. What do we call bounces off in middle school?
Reflects.
Reflect. Yeah. So it reflects the light from the sun. And that keeps everything cool. But if the ice melts, it makes it hotter. That's kind of a bad thing, isn't it? It's called a negative feedback loop, or positive, right? Positive, negative, negative, positive. It's a feedback loop. So the ice is going to help keep the planet cool, but the ice is melting, which makes it even hotter. Kind of crazy. And what does the dark seawater do?
It grows.
It absorbs the sunlight.
It absorbs the sunlight, which makes it even worse, right? So there's this feedback loop where the sun heats up the earth heats up, it melts more ice, which causes it to heat more, which causes the water to absorb more heat, which makes it even hotter. And it's like this, how do you ever get the poles back? Like this, the ice back? Kind of crazy. So do your answers match the ones on the board?
Yeah, explode the sun. Like, you need the sun.
All right. And there are 2 more questions. Which one has 0 of at the moment? Can I switch? Okay. All right. Why have wild areas shrunk around the world?
Because the sun is weird.
No, Tristan, not because things explode.
What do you mean? That's the answer.
That's been your answer for everything. Yeah.
Because like the population of people are going.
Okay. Human population is growing and growing and growing and growing. And we all want to live in our own house. We all want to drive our own car. Yeah? So, global population of humans,
Just begin the first.
Tristan, please, is increasing. The polar ice caps are melting, which is causing sea level to rise, which can take some small islands away and cover up existing beach boundaries, etc., etc. So human population is increasing, we're putting fossil fuels into the atmosphere, the ice is melting, which causes some land to go bye-bye for relatively ever. So why do you think we've got a better understanding of why Hank cannot turn the volume off on his phone? Why do you think that is? Why can't he turn the volume off on his phone? You know what I mean? It's just a mute button. Right? You go all the way down the volume until it goes away, and then it's a mute, and then
Instead of the global population, do we just write?
I can't play this. There's a time when I play it. I heard it. There's a note. Yeah, that's a sound. So why do you think we have a better understanding now of the natural world than we did in the past? Well, how is it that we know more about the Earth?
Because the company is stuck on Mars.
No, Christian, not because things explode.
He didn't even say something about this exploding.
Yeah, I said the communist.
I'm just going to say that. You're going to say that every time. Exactly right, Malia. Congratulations. Nicely done. We have better technology. We got satellites up in space. You can go look at your house on Google Earth whenever you want to. We've got documentaries and news programs all over the internet. Have you heard of the internet?
Yeah.
This little thing where you can go.
Are you really want to know what I'm trying to do?
Yeah, so we know a lot more about our world, and that's how we know what's up, what's going on. Now, I'll make you a deal. You guys did such a good job. Those of you that already have all the answers down, you don't need to take notes for this last 3-minute video. But if you didn't take any notes, you need to get it from your neighbor while you watch this one. So, put your pencils down. You don't need to take notes about this one, but I want you to pay attention to this.
You motherfucker.
Tristan, and I'm sorry, nothing explodes.
Before trying to work out the impact humans have, scientists have to account for natural variations in the Earth's climate. Key science involves a number of factors, all of which play a role in changing the climate. If this is a court case, they'd be our suspects. Many natural factors are known to cause changes to the climate. They include the sun. The energy it emits varies, and this can change the temperature here on Earth. Volcanic eruptions. The vast gas clouds they throw up can cause sharp global cooling as they affect the chemistry of the upper atmosphere. And climate cycles like El Niño that can cause global temperature fluctuations lasting many years. Climate scientists say they're 95% sure that recently all these natural factors have been overshadowed by one other. For most climate scientists, there's one prime suspect in this case: us. And that's because of a colourless, odourless gas called carbon dioxide that we're pouring into the atmosphere. One of the first people to try and unravel the role of carbon dioxide in changing the Earth's temperature was a depressed Swedish physicist called Svante Arrhenius.
Please don't talk.
Arrhenius wasn't interested in the Earth's warming, however,
Don't talk during the video.
but cooling.
Still
In
talking.
1894, Arrhenius' marriage broke up. Searching for distraction, he decided to try and solve one of the great mysteries of his time. The Earth had been beset by periodic ice ages over the last 2.5 million years. And this intrigued Arrhenius. On trips through Northern Europe, he studied the vast glacial landscapes that surrounded him and wanted to know how the Earth could possibly have undergone such monumental change. What had caused the planet to cool down so dramatically? Arrhenius believed the cooling of the planet was driven by gases like carbon dioxide in the Earth's atmosphere that acted like a huge blanket around the Earth, keeping it warm. He wanted to find out if reducing carbon dioxide levels could cause the climate to cool. The only way he could test his theory was to use maths to work out the relationship between changing levels of carbon dioxide in the air and the Earth's temperature.
Nurse? Yeah, you can go.
It was painstaking work. Every calculation had to be written out by hand. Arrhenius himself described it as tedious, but eventually he had his answer. He predicted that a halving of carbon dioxide in the atmosphere could lower the temperature by over 4 degrees, and perhaps trigger an ice age. Almost as an afterthought, he also calculated that a doubling of carbon dioxide could increase the temperature by the same amount.
Hey, 4 degrees.
Oh, God.
4 degrees is a lot. More than you know, people. More than you know.
Wow.
All right, don't need to worry about this question. You do have to get to choice now. This is a choice. Which video do you want to watch first? So there's the one that starts with dinosaurs, but it's about the mass extinctions. And here's one that starts with volcanoes, but it's about global warming and how it can lead to mass extinction.
Dinosaurs.
Volcano.
Okay,
Raise your hand
volcano.
for volcano. Raise your hand for dinosaur. And
Whoa.
dinosaurs have it 1 to 2.
I wanna watch dinosaurs.
All right, so here it is.
Yeah, we said volcano.
Extinction is the end of a species, and millions of species have experienced extinction over time. In fact, probably 99.999% of all species that ever existed are no longer there. Extinction is a way of life, actually, but there have been mass extinction events where a whole array of species go wiped out. And some biologists think the current rate of species loss is probably 1,000 times what the normal rate is. I'm Michael Novacek. I'm the Provost of Science here at the museum, but I'm also Curator of Paleontology. The collections in the museum here and other museums are really a record of life. Very important for not only telling us what went extinct, but what survived. So what follows? There are 6 tales of extinction.
These are 6 things that have gone
Tell us
extinct.
about the time we're living in now.
My name is Melanie Hopkins, and I'm an assistant curator in invertebrate paleontology. Trilobites are a group of extinct marine arthropods. Arthropods include things like lobsters and insects. There are sort of two main types of trilobite larvae. One appears to have been completely benthic. Benthic just means crawling on belly or something. And then there's another type of larvae, benthonic, swimming or floating up in the water. During the mass extinction at the end of the Ordovician, trilobite species with benthic larvae were more likely to survive. In some ways, this is surprising because there are a lot of good things about having benthonic larvae. A big one being that it's much easier to disperse further and ultimately end up with a larger geographic range. This is a really good example of extinction selectivity. And what we mean by extinction selectivity is that during a major extinction event, there are some organisms that are more likely to go extinct because of some aspect of their ecology, like what they eat, or some other aspect of their lifestyle, like in the case of trilobites, whether they had planktonic larvae or benthic larvae. By studying extinction selectivity in the fossil record, we can begin to understand what sorts of characteristics make some organisms more vulnerable to certain threats.
My name is Allison Bronson. I'm a PhD student studying fossil fishes at the museum's Richard Gilder Graduate School.
This is one of those jawed fish that we learned about.
Dunkleosteus was a placoderm. Placoderms are fishes with bony armor that covered most of their body, and it lived during the late Devonian from about 350 to 370 million years ago. Dunkleosteus is just cool because it's so big. Estimates have ranged up to 20 feet long. It was really one of the first examples of a big ocean-going predatory animal, occupying a role sort of similar to what we think of as a great white shark today. Dunkleosteus went extinct along with the rest of the placoderms at the Hingenberg event, which was a loss of almost 96% of vertebrate species at the end of the Devonian. Dunkleosteus wasn't the only large placoderm in the ocean at that time, but after this Hingenberg event, we only see smaller animals in the fossil record. And this is part of what we call the Lilliput effect. The Lilliput effect is something that we see at certain mass extinction events, where before the extinction, animals are generally very large, and after the extinction, animals are generally very small. We still don't really know what the explanations for this might have been, and there's probably more than one.
My name is Aki Watanabe, and I'm a PhD student in the Richard Gilder Graduate Program here at the museum, also in the Division of Paleontology.